Hi. So, I'm Louis Plissono. I'm the lead engineer of the Kubernetes team, and I'm here to talk to you about Kubernetes and also MongoDB in Kubernetes. So we have a few updates for you. And so we have both a community and an enterprise Kubernetes operator now. And I want to explain to you a few things. But before that, the main focus I want for this talk is simplicity. So the way the MongoDB database has been created is to have a simple way to store your objects natively. And the way Kubernetes is presented often is that it's a simple way to manage your workloads. So it should be like a perfect match. So let's see in practice. Kubernetes. I'm sure you've heard a lot about Kubernetes these days. It's very popular. And if you look, I think that's the first phrase on the Kubernetes website. What is it? It's a production-grade container orchestration, which means that you have containers and you have hosts or virtual machine. And Kubernetes is a way to put your containers on your virtual machines. So it's not as simple as it sounds. And obviously, the interesting features are automated container deployment. Like you don't want to manually choose where each container will go. Scaling up and down of your application depending on the requests they get, and management of your containers. So Kubernetes is a perfect fit for modern applications based on microservices with frequent deployments and mostly stateless. It has also automatic failover, recovery, scale, all these good things. What you see is that simple is not in the picture. So I don't know how many of you have tried Kubernetes, but many demos on the web show you how simple it is. If you want to do things yourself and in particular configure things that are happening under the hood, it's not as easy as it sounds. So in theory, it should be as easy as it sounds. In practice, I don't think so. So let's move on. MongoDB, document database. I'm sure you have heard about it a lot, and you have plenty of talks in this conference to present the latest features. I want to highlight a few things that are key in this talk, and in particular for modern application development. So MongoDB, first of all, it has a distributed architecture. That's the main thing. Like you never hear about a single instance MongoDB. Like even for testing, I don't know anybody who is using less than a 3 replica set, like 3 nodes. Like it seems like the basic minimum. So it has, and this is very important, especially in terms of Kubernetes and cloud native applications, because it means that from the ground up, MongoDB has been created in with a distributed architecture in mind. And obviously, like more old-fashioned databases have been first started with big database instances, like on big hosts used as database host, and they added distributed architecture only later on. So I think this is a key feature. And because of this, MongoDB is scalable. From the ground up, it has been built with scalability in mind. So you have both horizontal scalability and vertical scalability, I would say, or high availability. So horizontal scalability means that it scales with a write. Like if you have many write requests to your database, you can use sharded cluster, which allow the request to go to a part of the database, and you can scale horizontally your instances, which makes it friendly for write-heavy applications. On the other side, you have higher availability, which is a read-heavy workloads. So in this case, you can create replicas like replica set that store a copy of the data. And so if you have a read-heavy workload, you put like multiple replicas, and your readers can read from a different replica, and it scales a lot. So it shares a lot. So it's much more scalable. So it's both ways. So that's the key thing. And then it's obviously why is MongoDB popular, because it's intuitive and flexible. You store your object directly as you would have them in your application, and you can query them as much as you like, in more with a complex schema and the way you want. So distributed databases. This looks scary, and it is. So first of all, you have the CAP theorem, which states that you cannot have consistency, availability, and partition tolerance at the same time, which isn't good, because that's what you want. You want your database to be consistent. If one user sees something, you want the other user to see something. You want it available, like it's a no-brainer. And the partition tolerance means that if you have a distributed database, and you want to make it highly available, it means that it's, let's say, hosted by different cloud providers, probably in different, surely in different data centers, and probably even on different continents. What happens if a transatlantic cable breaks? Does it mean that your users in Europe will see a different thing than your users in the US? You don't want that. The bad news is that you cannot have everything at the same time. And the TLDR it's hard. Then what's next? Internet scale database. So this is again about the availability. I mentioned above, if you have users in Asia, Europe, the US, will they see the same thing? So this is consistency. Will they see the same data? Will it be available at the same time? How will it survive partition in the network? This is very hard and very scary. And then the last point is fast read and write. If you want to be able to read and write fast, I said in the previous slide that you should scale your database. So scale horizontally with sharded cluster, or high availability with replica set. But it means that you will have more nodes. More nodes mean more possibilities to have things go wrong. And so TLDR is hard. And should you care about that? As an application developer, the only thing you want is to have your application running and use the database. Okay, maybe you have a few more requirements. You just want to have your application running all the time. You want it running everywhere. You want it scaled up and down. If nobody is using my product, I don't want to pay for nothing. At the same time, if my product is becoming very popular, I don't want user to be prevented to access my product. Also, I want always the latest version. If I have a bug fixed last week, I don't want customers from this week to hit it. This is a no-brainer. I don't want to lose data. I put it there, but it's not even a requirement for any application developer. Data cannot be lost. And we have many customers that are in banks, in insurance, and not lose data is the number one feature they want. But I consider it as a no feature. It's a granted. And you have many more. So where I'm going to there. We have the MongoDB Kubernetes operator. With it, in a single command, you can have a MongoDB replica set or sharded cluster deployed. So replica set is more for high availability. Sharded cluster is for horizontal scaling for writes. In a single command, you can handle your MongoDB users, because obviously, something that I didn't mention previously is the security is very important. You want your application to be secure, and you want the users to be able to access their database, their data in the database, but not others' data in the database. So it's very important, and MongoDB has a lot of features for security also. And then if you want monitoring and backup of your database, which seems like a very good idea, we have a dedicated product for that, which is Opsmanager, which has been time proven, and you can also now deploy with a single command on Opsmanager. So, and obviously you can have a single command to do all the three of this. So the agenda of the talk. First, I will do a brief description of Kubernetes so that you are all aware of what I'm talking about and what are the great features of Kubernetes. Why is it becoming so popular right now? Then the big thing is that we have announced the Community Operator GA, and I will show you the main features and a small demo. Then we'll move to the Enterprise Operator, which will where I will describe you the latest features of the operator. And finally, Opsmanager in Kubernetes, which is the latest feature of the Enterprise Operator and has been long awaited. So let's start with Kubernetes. So I will try to do my best to give you a simple introduction. So first point that is very important, it's a declarative configuration. This is for robustness, because you describe the end state, not the way to get there, which means that if something breaks in the middle of getting there, it doesn't matter. The end state is the same. And that's really the main thing that Kubernetes has been designed for high reliability. So one of the main goals is that I put in the backing database of Kubernetes, which is here in the schema at etcd. I put the state there. If anything breaks, I come back up and I get the state, and then I figure out the way from where I am to where I go. If you ask core developers of Kubernetes or advanced users, the number one thing they like is the API server. So there is a single API for everything, for the control plane, for the data plane. So it means that it's easier to compose and extend Kubernetes, and that's why it has become so popular. So all the controllers that check the state of the objects, they talk to the same API. The users, when they apply some changes, when they want to install something, they talk to the same API, and all objects are stored in the same place, in the same state, which is great for stability of the platform. And the last point, out of many, but I had to choose a few, is that applications do not know, and ideally do not need to know, the environment they are running into. And this is for the ease of deployment and adoption. So the underlying host or cluster is abstracted. So you shouldn't care if, and especially in Kubernetes, that is really true, if your container is running in a private cloud, like in your own data center, or in a public cloud, any of the big three, or in another platform as a service provider. Kubernetes abstracts that for you, and that's the beauty of it. In theory, I know I talked about theory and practice before, but in theory, you can move your application from one cloud provider to the other. If it's running on Kubernetes, it should be like no action for you, like no change from you in your Kubernetes deployment procedure. So I want to talk about the application architecture in Kubernetes, because most likely you're here as an application developer who wants to use MongoDB in Kubernetes. So let's talk about application architecture in Kubernetes. So from the application perspective, applications run inside a container. And there is a single responsibility principle, which is one process per container, which makes it very easy to understand what is going on and to monitor. Like really easy to monitor, that's the key thing. And I know many people consider containers than virtual machines. They are not exactly virtual machines. They are very lightweight virtual machines. And the key point here is that because they are lightweight, it's like more big processes. Like it's more a container. I see it more as a wrapper around the process than a small virtual machine, which allows you to have one process per container, which makes it very resilient, especially because container can restart and it doesn't affect the other processes in this case. So right from the start of Kubernetes, there have been this principle of one process per container, and the consequence of this principle is that you have pods, which are a set of containers, because many applications require more than one process to run, and that's because we want to enforce one process per container. We have to have multiple containers for an application. And so the real entity of an application in Kubernetes is a pod, which means like a multiple set of containers. And then a node in Kubernetes is just a host, and you can have multiple pods hosted on a single node, and they should be independent of each other. And then a cluster is a group of nodes. It can be individually managed or via a public cloud. And all the big public clouds provide Kubernetes offering, so you don't need to do anything else. And we will see that soon in the demo. So if you search the web for the top reason to adopt Kubernetes, you have plenty. I've selected a few of them. So you have a faster time to market. What it means is that you have an improved app development and deployment time. So as soon, and if you have everything set up, like ideally, you can have your developers push code which runs the test automatically, create the artifacts and the containers automatically, which push them in a staging environment, in a pre-prod environment, and automatically to prod without having any action, because it's all handled by Kubernetes if it's caught by multiple test features. Also, one of the top reasons, it's on the other side, not on the developer side, but like IT cost optimization. Kubernetes, I said at the very beginning, is like a management of an orchestration of containers. And if you design your applications well and put the right containers at the right place, you can obviously stack them and make them much more efficient. So instead of needing one machine for every application, maybe you can stack two different applications on one machine. So that's one of the key features. There is also improved scalability and availability feature. This comes Kubernetes has auto-scaling feature like at the very root, and it's very important. So it allows for handling increase in workload nicely, and also saving costs when you don't need to have all the instances of the application running. One of the top reasons is also multi-cloud flexibility, that you can, because Kubernetes is now your platform, the fact that Kubernetes is running on one cloud provider or another, it's not as a big deal. And it also provides, in the same vein, a seamless migration to the cloud. If you migrate your application and your data center to Kubernetes, then you can have one cluster in your data center and another cluster in a public cloud. So the typical Kubernetes application, the number one by far is stateless applications. I'm sure you have seen by now 10,000 Nginx demos. You have self-healing and scaling services. So in line with the Nginx demo, you have an Nginx demo, which is a simple web server, and you put like plenty of web requests to it, and you see that automatically you have a second instance of your web server coming up so that it can handle more load. And when the requests go away, the extra instance of your web server is going away too. So that's the best of both worlds. Then serverless is very popular, and Kubernetes is often associated with it. I mentioned again hybrid and multi-cloud. So hybrid is more like private and public cloud, and multi-cloud is multiple private or public clouds. What you don't see as a typical Kubernetes application is databases. And because you are in MongoDB Live, that's a problem we want to address. And that's why we have done all the work we have done in my team for handling MongoDB in Kubernetes. So the last slide about Kubernetes is the difference between controller and operator. If you look, we have announced we have an enterprise operator, we have announced the community operator. So what does it mean, controller and operator? So a controller, it's an instance that monitors the expected and the desired state of the resource and make changes if needed. As I mentioned earlier, you want to see like the desired state. So a user is modifying the desired state of a resource. The controller is checking that state periodically and making changes to the resource you want to see that way. So a controller is like a Kubernetes controller. So it monitors what I mentioned earlier, the containers, the pods, the nodes. An operator, it's exactly the same, except it's for custom resources. So a custom resource, it's a resource that is custom for you. So usually it's built on top of Kubernetes resource. And for what we are interested in here, like for example, a MongoDB resource is built on top of a stateful set Kubernetes resource. And the operator will check what is the state of the MongoDB resource and what it needs to do moving forward when you have one more replica in your replica set or when you create a resource. So we'll see later what is happening, but like the main thing is that our operator, they try to rely as much as possible on Kubernetes. So when we instantiate a MongoDB resource, it will in turn instantiate a stateful set that the Kubernetes controller, the stateful set Kubernetes controller, will pick up and then instantiate multiple pods to fill the stateful set and so on. But we'll see that later. So the community operator. So the big announcement is community operator GA, which means that you can use the free open source MongoDB operated by a free open source Kubernetes operator. And that's exactly what we want. Like you want to use MongoDB because it's convenient, because it's modern, because it's scalable, because it's flexible. All of this, you want to be in Kubernetes because that's the way to deploy modern applications. You shouldn't have to worry. And now you don't need to worry. So, as I said, it's free and open source. It's fully functional. It offers all configuration from the community MongoDB. Not all is available as of today, but soon enough it will be there. And one big thing is that it's secure by default. And which means that you need to set up the TLS certificate and all that. But I'd rather you spend a bit of time setting up the TLS certificate rather than having a non-secure database communication. Obviously, it's in GitHub and you can see it there. So the architecture. I don't want to spend too much time on the schema. It's a bit complicated because it's the whole architecture. I want to emphasize on a few things. So we really wanted to use as much as Kubernetes as possible. Kubernetes is making a lot of progress. There is a big release every quarter, and it's like over a couple of years, it has made so much improvement. And so we are using like really native Kubernetes features like stateful set, persistent volume, the readiness probe, and the sidecar container. So we designed the community operator as a simple design in mind and with the smallest overlay on top of Kubernetes primitives. And we could do that because there is a MongoDB agent that is running next to all enterprise MongoDB instances to help manage the database. And this MongoDB agent is like I think the second application developed by MongoDB outside outside of the pure MongoDB. We had an agent right from the very start. To be able to handle the configuration of MongoDB, because as I told you, a distributed database is not an easy beast to handle. So we really needed to have that. So this Mongo agent that has been designed for like many years has been integrated in our design, and that's really a key feature. It's running as a sidecar container, which means that it's a small container next to the main MongoDB container, as you want, one application per container, and it's just working. You upgrade, downgrade, and have secure communication. So instead of spending more time on the schema, I will do a demo now. So the main thing about the demo is that I want you to see all the steps you don't have to do. And because you don't have to do them, you won't see much, but like that's the beauty of it. So let's start. So I have a Google Cloud, an empty Google Cloud. There is nothing in it. So I have a cluster with one cluster with one pool of nodes. I've enabled also auto-scaling from 1 to 3 nodes, and that's it. So I have one running because the minimum is 1. It's a free tier that I took, so you can put the same demo. So there is nothing there. And here I have check out the MongoDB community operator. So first of all, I want to apply the operator. So if I watch, so the operator, I mentioned it's very simple. It means that it's very fast. So you see, I created it less than 3 seconds later, it's up and running. So now we have in our services one operator. That's it. Then what do we want to do? We're here to see a MongoDB database. So I apply, what is it? CRD. So I started applying that. Let me show you what I applied. That's, 6 lines to get a fully replicated database. So you just specify the API version, what I'm talking about, MongoDB, I specify a name, and I specify the number of members, the type, replica set, and the version. So what is worth noting is that MongoDB, we don't actually provide the containers. We use the containers that are already maintained by the community. So you can use the containers hosted by Docker, by Bitnami, whatever. And that's one of the key things of this design. We didn't want to take over anything else. So you see that we have already one instance running, a second instance running. On the upper right, it's all the pods, and the W means that you watch every a few seconds. It's updating what is going on. So what is going on? It's pending. So describe what is happening in this pod. Oh, we didn't have enough memory. So I set up my cluster with auto-scaling. In fact, my node pool with auto-scaling here. And so at first I had only one node, but because now I'm requesting another element in the node, it's starting a new one. So it was unavailable. It seems that something is moving. Now it's already there. So I started my demo. I had nothing on my cluster. I had one node because I told Google Cloud Platform to at least have one node so that it didn't take too long to start. And then I put my lightweight operator. It took me, as you saw, like 3 seconds to have it running. Then I decided to show you a MongoDB instance. And we have created 1, 2, 3 replica sets. Still not finished. So it's still initializing. But we're talking like 3 minutes. Let's see how long it takes with the talking to get the database. Let's see. Okay, almost there. So if you see in the ready, you have 2/2, 2/2, 1/2. This is the number of containers running in your pod. As I told you, we have a Mongo agent, which is handling the database and the database. So in total, we are talking 3 minutes to get a full MongoDB 3 replica set working. And 3 minutes with the instantiation of an extra node because I put the memory requirement so that we couldn't have enough memory on only one node. So I found this very cool. But then what else? So we have this, we have the operator, we have the MongoDB, which is a stateful set, which is a native Kubernetes pod configuration for stateful workloads. And we have, so this is how to access your Kubernetes cluster from the outside. And so if I want to access it from here, obviously, this is not for production. Like, if you want to set up the ingress to your services from outside of your cluster, you should think about it carefully and handle that with proper permissions and all that. For now, I just want to show you in my demo, so how to access it. So if I paste that, so you have, so you connect to the cluster, and then you ask Kubernetes, so the local Kubernetes, to forward my 8080 localhost port to my database. So here, if I do Mongo localhost on port 8080, guess what? I'm in the database. So there is a desk database. Obviously, what is the collections? What are the collections? Oh yeah, I created a test collection where I put a few things before. And this is a key feature. Like if I do, so Kubernetes has a feature called persistent volume. So I did a rehearsal of this demo previously, like 3 hours ago, and it has created volumes, persistent volumes that are in GKE in the Google Cloud. When I started this demo, there was nothing happening. Like there was nothing running, but the data was still there. When I bootstrap it, as I show you, in 3 minutes, I get my previous data. And obviously, I can do db.testcollection.insert one more, like that. Oops, it's JSON. And so I have my 3 elements now. So I think that the key things I wanted to show you in this demo, and obviously I accessed it from the shell, but this is accessible from any programming language with the driver, and yeah, that's what we wanted. So yeah, all the steps we didn't have to do is to get the MongoDBs to talk to each other to set up the replica set, because obviously when I put something in the replica set, it's replicated on all the nodes and you can access it through anywhere in the instances. So now let's talk about the enterprise operator. So we have added a few features, quite a few features in the Kubernetes enterprise operator. So the latest one are external access. So I mentioned in the demo that you don't want to access using port forwarding for production workload. And in fact, I could do that because I have access to the Kubernetes cluster with my kubectl command. So I use that to forward the request inside the cluster. This is not a production workload. In production, you should configure external access with your driver, with your programming language driver, and this is all handled by the enterprise operator. We also provided pod template, which is a way to configure, to fully configure how you want your pods inside Kubernetes. So I showed you that there is a MongoDB resource that you can specify like very quickly, like with 6 lines saying that, oh, I want a replica set with 3 members, which is named something. So that's one of the simplest resource you can create. But if you want to nitpick and to say, oh, I want my containers to have that much memory, or to have an extra sidecar, for example, like a daemon set, like if your enterprise is using a monitoring application and sending dedicated monitoring to, let's say, Prometheus, you can also configure that with a pod template, which is very, very useful. Then security is a big concern of us. So we have Scrum SHA, so which is authentication through challenge response, password. We have also custom certificate support, which means that you can have a certificate authority in your enterprise, and we use that to authenticate to the database. We have OpenShift support, like a full OpenShift for support, which is like the Red Hat solution for Kubernetes, and which is very popular on our enterprise customers. What are the coming features? One of the big one is LDAP, which is requested by many customers. So you don't want to handle your users for MongoDB and LDAP differently. So this is coming very soon. Then you have multi-cluster. So this is very long-term project, which means that you can have, I showed you my GKE cluster. It's a single cluster. Ideally, we want to provide multiple cluster, which will allow for multi-cloud and everything. So that's a long-term project. So, but it's very exciting because this will allow us to do like multi-cloud and hybrid like much better than what we do now. Then there is an encryption at rest, which is one of the key features of MongoDB. Like you can have and it's very important for enterprise customers because if you use a public cloud, all the data is in the cloud, which means that in theory, if the public cloud provider could, or if there is a breach, somebody could access your data in the public cloud. With encryption at rest, it means that the data you put, and if you put it in the cloud, the data you put in the cloud is encrypted, and nobody can decrypt it until it has the encryption key. So if you keep the encryption key in your enterprise, and your application is encrypting the data when it's putting it in the public cloud, nobody can ever access this data until they have the public key, which is very important. And so this is like a key feature to allow users to move to the cloud, and in particular users who have very high security requirements like banks or something like that. And then I put autonomous operations, which is so as if you're familiar with MongoDB architecture, like Ops Manager is involved in a lot of operations. We have done so. You've seen that in the architecture for community operator, we don't have Ops Manager in the picture because Ops Manager is an enterprise-only feature. But it's fully working. And in fact, we learned from that, and we see that in many cases, we don't even need Ops Manager to do the operation from Kubernetes. So we simplify the way the enterprise operator is working. I didn't mention in the recent features for enterprise operator Ops Manager and Kubernetes, but that's the big one. So this means that you have only one way to you can have one way to manage all your database all natively in Kubernetes. So Ops Manager, a quick reminder is that it's a tool that allows you to manage your MongoDB database. It provides a nice UI. You can have monitoring, and you have backup. That's the main features. Historically, it was not super easy to set up, and you had like you often had to use support to be able to get to working installation, because Ops Manager is obviously backing everything in a MongoDB database, which means that you had to create first a MongoDB database. If you don't have a Kubernetes operator to do that for you, it's not that simple. And then you have to plug it in there and everything. Now with Ops Manager and Kubernetes, you can do that in all in one command. Like you specify your configuration, which can be very simple. Like I want an Ops Manager with a backing database with 3 replica set, and that's it. It provisions everything. The backing database and all the new databases that will be able to use Ops Manager, and the backup is included. So you have all the backup infrastructure that is ready to use and ready to back up your data. If you want more updates on the enterprise feature mostly, you can see the talk from Andre, which is a product manager in our team. The talk is titled Kubernetes, MongoDB, and the future of your data platform. And I think that's all I had for you. Thank you for listening. Bye-bye.